I mean, I'm not a businessman like the previous speaker. I am actually a researcher and a university professor. I want to throw my ideas to the businessman if they think that there are potentials to exploit our research in the area of water technology. That's what I'm going to spend 15 minutes. And I have got already an exhibition, booth number 33. If anybody is interested to know about what sort of materials we develop, we have got some example in the booth 33. You can see the title of my talk, Water. Now, how many of you know about the nanotechnology? I mean, I know that people talk about energy, people talk about the circular economy talk. I thought that there is a correlation between my talk as well as the circular economy. I'm going to give you some examples about the challenges we face in the current world about the water problem, pollutions, and how we can eliminate those type of problems. So you can see that I've given some examples of sorts of materials. Like this type of materials, you can think about replacing bones, bone replacement material. Similarly, if you look the smallest particles, they could be very powerful to capture any sorts of pollutants from water. So what I wanted to say today, I'm going to give you some challenges related to, these are the ongoing projects related to the water technology, and that's the reason I'm over here today. And you can see the reason behind my presence over here, that European Commissions, they have invested a lot of money on water technology, clean water technology, and one of the important areas is nanotechnology, where you can develop nanomaterials to clean water. Okay? And these are the projects, but I'm not going to go through all the projects, but I want to say something about the challenges. You know that we live in a world where, depending on the location of the place where we live, you have got a lot of contaminations like arsenic. And you know the arsenic is very, very poisonous, and it's present in the groundwater. And it's not only in Europe, it is in America, it is in Asia, everywhere, groundwater contaminations of arsenic. So we have got challenges how we can actually remove arsenic from water or the groundwater or the soil. Then if you think about the bugs like Legionella, Salmonella, those are the bugs which can be present in like water, and then you know that there are a lot of incidents where people get unwell due to the consumption of frozen food, and that food also can have lots of bugs. And those bugs, whether you can remove them by using sorts of nanotechnology. Then if you think about the next one, which is directly relevant to the first lecture about the circular economy. And one of the questions came from the audience, what will happen to the Tesla battery, lithium, which they are using for their, the power generation. And I can tell you, the statistics, if you think about each and every electronic goods run with energy, and those energies are coming from the battery, and the battery containing all sorts of toxic metal ions like cadmium, and at the same time you can think of valuable metal ions like silver. So how we can actually use those type of valuable metal ions from those batteries. And if you think about the European legislation, that they are encouraging people not to throw the battery in the landfill. But there was a recent statistics that 80% of the people, they throw their batteries into the landfill, and when they go to the landfill, you can think about what will be the consequence. All those ions are actually polluting the soil, polluting the water, and that has gotten very big consequence to the whole ecosystem, like sea animals, humans, everywhere. So what we are saying today, that how our technology, nanotechnology, can help to actually remove the pollutants from the water. And we have a nice booth in 33. We have brought some materials for showcasing. So if you are interested, you can go over there and have a feeling about what sort of materials we are preparing in this context. Now you can see that these are the challenges, but why the businessman will be investing money to do research. And you can see the market is about $400 billion in terms of the total water technology and how you can actually provide the water to the world populations. And if you think about the world population is growing like exponentially, yeah. So if you think about 2030, we need so much of water, and that's a big challenge. And if any company come up with some sort of ideas, then we can provide the materials and then come with the technology, and then the total market, you can see from the Dow water is $400 billion. And you can think about the sectors, like if you go for industrial sectors, which is in 2030, you can see that 22% of the global water demand will increase industry. If you go for residential market value, and then if you go for wastewater, water reuse, again the growth is 15%. So we need some sort of technology to use nanotechnology to deal with these challenges, and working with the businessmen to come up with sorts of solution. So what I want to say, I don't want to go to the science, but you can see that there are so many ways one can actually remove the pollutants like toxic metal ions or biological like bugs, and so much classical materials you can see here that people have used sand, soils, all those materials to remove those bugs. But here we are talking about some novel materials under the nanotechnology, which is basically very, 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 very tiny nanoparticles which you cannot visualize through your open eyes. But we can manipulate as a researcher or a chemist or a scientist, and if you make them, in a way we want, water, wastewater treatment. And you can see that what we are saying here, if you make a porous materials like bones, you increase the surface area of the materials, and those materials can be very powerful. If you make some sort of antimicrobial small particle, that could be very powerful for killing bugs. Similarly, if you go for magnetic, you can throw in the water and then they can capture all the bugs and toxic metal ions, and you place a magnet, they can go towards the magnet. So you can have a clean water system. Similarly, if you have materials which can actually, in the presence of sunlight, they can kill the bugs. So we can combine together to form a technological materials that would actually work for all sorts of applications. So what I wanted to say here to finish with that these are the materials we develop, and these are the electron microscope image of those materials. And if you want to visualize these materials, I can recommend you to go to booth number 33. You can have feelings about the materials, how they go towards the magnet, and how you can clean the water, from the pollution. So these are the different types of material. This is the membrane material containing, the silver, which is antimicrobial. This, if you look over here, the extreme left, these are like a spherical particle, which is again magnetic. So if you apply the magnet, they will go towards the magnet. If you remove the magnet, they come into the solution. So these are the very powerful materials. Unless you know the science, you will not be able to make it. And then you can see that we have actually managed to make a commercial product with the company in Germany. And this product is actually to capture all the foodborne microorganisms from food samples. And we are trying to build the similar product in the context of capturing E. coli from water. Okay, so you can see that we, as a researcher in the university, we are presenting in a Tech Connect event. The reason behind that, we know the science behind, we know how you can apply the science to the market, and I'm looking for people who are really curious to know about water technology, and if they are interested to do some collaboration with the university, and that's the reason I'm over here today. And with that, I think I finish this talk, and if you are really keen, I'm ready to answer any questions in this session, and I welcome you to go to booth number 33 to see some sort of materials what we are developing. Okay? Thank you very much for your patience, and I'm happy to take any questions from the audience. Okay?